Good morning, everybody. Um, Hopefully, you had a pretty good spring break. I know that kind of seems to be Groundhog Day, probably. I know it is for me. I'm getting tired of my kids, I think. um, but, anyways, we're going to go ahead and kind of go over this lesson here today. We're going to do just kind of review here for a second, just kind of since we've come back from spring break, and I know that you guys got a lot on your plate probably with the new assignments for this week, so we'll go ahead and kind of keep this a little bit short. But just to remind you guys what a chord was, a chord is a line inside of the circle where the endpoints are on the circle. Tangent line is a line outside of the circle where one point, that line intersects the circle at one place. And then a secant line is the same thing as a chord. However, a secant line actually goes through the circle itself. It intersects the circle at two different locations, but it's just going to go through the line itself or through the circle itself. So just kind of a review here for this, and what we're going to talk about today is intersections of two secant lines inside the circle and a secant line and a tangent line that intersects on the circle itself. So let's look at that for a little bit. So here I have two secant lines that intersect inside the circle. I have this secant line AC and this secant line DB. They both intersect inside of the circle. So the question is, how do I find the measures of angle 1 and angle 2? So in order to find, of course, we know that angle 1 right here, this measure of this angle is going to be the same as the measure of this angle right here because these two are vertical angles. So in order to find angle 1, I'm going to add the intercepted arcs of each one of these. So for instance, the intercepted arc of angle 1 is AB. The intercepted arc of its vertical angle is DC. So these are my two intercepted arcs for these angles, right? I will add these intercepted arcs together and divide it by 2. So let's say that, well, we'll look at an example in just a second. And so the same thing here for angle 2. Angle 2 has an intercepted arc of BC and AD because these two angles are congruent. So I will add this arc plus this arc and divide it by 2 to get this angle right here, which is also this angle right here. So let's look at an example. So here we want to go ahead and find what angle X is. All right, so we're going to go ahead and take these intercepted arcs. All right, I have an intercepted arc of 88, and I'm going to add that to the 76, and I'm going to divide it by 2. Let's straighten up this pad here a little. All right, so calculator, 88 plus 76 divided by 2. And that's going to give me an angle measure of 82 degrees. All right, and so if this is 82 degrees, then of course this is 82 degrees as well. Now, how would I find out what angle I is? All right, I want to know what angle I is. Well, these two angles right here are a linear pair. So if I wanted to go a little bit further with this and ask you what this angle was right here, I would take this 82 degrees for X and subtract it from 180 degrees, and I would get angle I is 98 degrees. All right. So again, here we have a situation where we're looking for X, but this X right here is not one of the angles represented by these two intercepted arcs. So I'm going to have to do what we did just a second ago. I'm going to find what this angle is right here, or angle Z. So we'll take 96 plus 62, and we're going to divide it by 2. All right, so 96 plus 62, 62 divided by 2, and that's going to give me an angle measure of 79 degrees. All right, so this angle measure right here is going to be 79 degrees. So because this is a linear pair right here, that means that x is going to be 101. All right. So now the question is, all right, I have the angle, and I have this intercepted arc, and I have this intercepted arc, so the process still remains the same. I'm going to take the arc, the intercepted arc here, plus the intercepted arc here, divided by 2, and set it equal to the angle. So in this case, now my arc is x plus the arc that I know, which is 25, and I'm going to divide it by 2, which will then give me the angle that it intercepts. So then I have to just go ahead and solve for x. So multiply both sides by 2 to get rid of this 2 in the denominator over here. And so we have x plus 25 equals 120. Yes, 120. So therefore x would equal 95. All right, so that's going to be the value of x over here, 95. So your excuse me, the questions on the assignment will look very similar to this. So this is an example right here where I'm looking for the arc. So I would go ahead and take the intercepted arc of x plus the other intercepted arc of 71, and I'm going to divide it by 2 and set it equal to the angle measure of 81. So therefore we have x plus 71 equals 162, and 162 minus 71 is going to give me an angle measure, or an arc measure, of 91 degrees. All right, down here, we're looking for this angle measure right here. So again, I'll take the arcs and divide it by 2 to find the angle measure. So I would take 203 plus 51 divided by 2, and that's going to give me the arc that I'm looking for. So we have 203 plus 51 divided by 2, and that gives me an angle measure of 127. So then finally, we're going to incorporate just a little bit of algebra into this. In that now we have to find the value of x. I have an arc. I have an angle. I have another arc. So I'll do the process the same way. So I'm going to take my arcs, where I have 169 plus the other arc, put that in 17x plus 2, and we'll divide that by 2 to set it equal to 111 degrees. All right, add the arcs, divide by 2, set it equal to the angle. So then we just go ahead and simplify from here. So we have 17x plus 171 divided by 2 is going to equal 111. So multiply 2 to both sides, and we have 17x plus 171 equals 222. So then we have 17x is going to equal 222 minus 171 is going to give me 51 degrees, or 51. And so 51 divided by 17 is going to be 3. It's going to be my value of x. All right. So that was two secant lines that intersected inside of the circle. Now we're going to look at a secant line. This line right here, AB, is a secant line intersecting with a tangent line, A, on the circle itself. All right, so whenever you have a secant line and a tangent line, we're going to go ahead and have them always intersect on the circle itself. So it really doesn't become any different than what we had talked about before with an inscribed angle. Remember that an inscribed angle was an angle that, if I had an inscribed angle, let's look at a different color here. An inscribed angle was one that we had the angle itself, the vertex was on the circle. So if this angle was 30, this arc was 60. If this arc was 90, this angle was 45. So the angle was half the arc. The arc was twice the angle. All right. So that's the same thing here. Here I have an angle that's created by a secant line and a tangent line, and this angle has its vertex on the circle. So this angle 1 is half the value of AB, or AB is twice the angle, or twice the measure of angle 1. And that's what this is saying right here. Angle 1 is half the measure of AB, and angle 2 is half the measure of ACB, which is its intercepted arc. So let's look at this. I want to know what QPS is, what this angle is. Well, this angle has an intercepted arc here up 250 degrees. So naturally, the angle QPS is going to be half the arc, which is 125. All right. If we look here, BCD, I want to know what BCD is. Well, I don't have an angle here. That's going to be a problem. So let's go ahead and find this arc. All right. So this arc right here, let's move this a little bit closer. Okay. This arc is going to be, sorry guys, my tablet doesn't let me go over to that part of the screen for some reason today. So let's go ahead and just, all right, so we have 216 degrees. All right, so this is my angle. The intercepted arc is right here, so it's 216 degrees. Now I want to find what BCD is. Well, if I subtract that from 360, subtract the 216 from 360, minus the 216, that's going to give me what the angle, or the arc BCD is going to be. So 360 minus 216, and that's going to give me an arc measure of 144. Okay. So again, your problems in your assignments are going to look like this. It's the same thing. Here, I have an arc measure of 80 degrees, and we want to know what this angle is right here. Well, naturally, this angle is going to be 40 degrees. All right. The angle is half the measure of the arc. All right, same thing. If I have an angle measure of 66 degrees, and I'm looking for this arc, I'm looking for this arc. Well, then we do the same thing. I want to go ahead and find what this angle or this arc measure is right here. Well, this arc measure is 132. And I'll take this 132 and subtract it from 360 to find the balance. So 360 minus 132 is going to give me an arc measure of 228. All right, and then last, we're going to have some algebra here. Okay, nothing too complicated, but we want to know what the value of this x is right here. Well, again, this is the same way that we did the last problem, only that now I need to go ahead and find what this arc is. And let's see. This arc right here is going to be 140 degrees. So I'll take this arc right here and add it to this arc right here and set it equal to 360 degrees. So I have 45x minus 5 plus 140. and I'll set it equal to 360 degrees, and I'll go ahead and solve for x. So we have 45x x plus 135, and that equals 360. So 45x equals 360 minus 135. That gives me 225. And so 225 divided by 45, x is going to equal 5. All right. So this assignment that you have coming up is going to be due tomorrow by 10 p.m. Okay, and then we'll go ahead and work on. I'll post an assignment on Thursday that will incorporate where we have secant lines that intersect outside of the circle, a secant line and tangent line that intersect outside of the circle, and two tangent lines that intersect outside of the circle. We'll go ahead and do an assignment on that on Thursday that will be due on Friday, and that will be your assignments for this week. So again, if you have any questions, email me, call me, um, post something on Classroom, whatever you need to do to get a hold of me, and I will do my best to be as timely as possible in getting those answers back to you. So hope everybody is doing well. Miss you guys, and we'll catch up later. See ya.